Math 161, Chapter 1.1. This section will contain linear equations and absolute value equations. Okay, a linear equation is a first degree equation, which means it's an equation and the exponent of variable x will be 1. So, for example, here is an example, equation 3x plus 2 equals 0. So since there's an equation, this an equal sign, this is an equation, and the variable x has the exponent 1. So this is the first degree equation. So when we solve the equation, always make sure rewrite everything so that the left side of the equation will have only one x and the others will be on the right hand side. Then the expression on the right hand side is the solution of the variable x. Okay, so let's try solving this equation. Okay, 3x minus 5 equals 7x. So what we're going to do is we're going to collect all x terms first so that we can write x on one side. So what we do is minus 7x. Okay, let's move 7x, the variable term 7x, from the right to the left. So minus 7x, minus 7x each side, then add. Then 3x minus 7x is negative 4x, minus 5 equals, this one cancel out, so negative 11. And then we want to leave x term on one side, so move negative 5 to the right hand side. So we have to do what? Plus 5 each side. So negative 4x equals negative 6. And then we want to remove this negative 4 so that the left hand side is only x. So what we do is divide each side by negative 4. Okay, divide each side by negative 4. Then x equals positive. So negative 6 over negative 4 is positive 6 over 4. Then you can reduce it. So 3 over 2. So this is the solution. What we did is collect all x terms on one side and collect constant terms to the other side, and then make x be on one side only. So this is the solution. Okay, let's try the next example. Okay, solve this. This equation looks complicated, but what we have to do is distribute so that we can remove the parentheses, and then simplify each side and collect x terms. So x minus multiply negative 5 and 2x is negative 10x. Multiply negative 5 and negative 7 is positive 35. Okay, on the right hand side, 3 times 16 is 48. And 3 times negative 5 is negative 15x. And then plus 5. All right, so let's simplify left hand, the right hand side. So on the left hand side of the equation, 8 and 35. So we can add this 8 and 35. So 43 minus 10x equals, okay, 48 plus 5 is 53 minus 15x. Now we simplified each side of the equation, and then let's collect x terms on one side and the other terms to the other side. Okay, so why don't we move negative 15x to the left? So plus 15x each side, then 43 plus 5x equals 53. And then also, now we have a 5x on one side, so only one term, one variable term on the left hand side. So move 43 to the other side, minus 43. So 5x equals 10. And then what we do is make x on one side. So divide each side by 5. Then x equals 10 over 5, which is x equals 2, right? So that's the solution. Okay, this is just a simple explanation and a simple equation. So this is not hard. But next example is about, it's an equation containing fractions. But when we have a fraction expressions, then we need to remove the denominator. Is much better. So let me go on to the next example. Okay, this equation has fractions. So okay, the best way is to remove the denominators. In order to remove the denominators, we need to find the LCD. LCD is the LCM of the denominators. Okay, LCM of the denominators. So the denominators are 5, 3, and 5, 10, right? 3, 5, 10. So the LCM always comes from, LCM is the common multiple. It's the common multiple of this number. So common multiple means the common multiple comes from the largest number. So 10 is the largest number. So let's check whether other numbers are multiple. 10 is a multiple of other numbers. 10 is a multiple of 5, but not 3, right? So get the next multiple of 10, which is 20. And is 20 a multiple of 5? Yes, but not 3. So find the next multiple of 10, so which is 30, right? Now, 30 is a multiple of 5 and also 3. So 30 is the common multiple, the least common multiple. So in this case, the LCD is least common multiple. LCD is 30. The least common multiple of denominators is 30. So next step is we're going to multiply. Since 30 is a multiple of the denominators, 5, 3, and 10, we can multiply the equation by 30. Okay, so since we found the LCD, multiply the equation by the LCD. That means multiply the left-hand side and also the right-hand side. So let's multiply this, the left-hand side, by 30. So let me rewrite the equation. This means 30 times 2 over 3x plus 30 times 3 over 5, 30 times 7 over 3 minus 30 times 3 over 10x. Okay, basically, when we multiply the equation by the LCD means multiply each term in the equation by the LCD. So can you see this part? Okay, 2 over 3x. So I multiply the first term by 30 and second term by 30. Also on the right hand side, 7/3 by 30 and also negative 3 over 10x is multiplied by 30. Okay, so next, since 30 is a multiple of denominators, they all cancel out and they're reduced. 1, this is 10, right? And this is 1 and 6. 1 and this becomes 10. This becomes 1 and 3, right? So let's write the equation again. So the first term is 10 times 2 is 20x plus 3 times 6, 18 equals 10 times 7 minus 3 times 3 is 9x. So as you see this, there's no denominator. Denominator is gone, so it's much easier to find the solution. So let's move minus 9x to the left. So what we do is remove negative 9x by adding 9x. Okay, so that is 29x plus 18 equals 70. And then move, since we have a 29x, x term on one side, move 18 to the right by subtracting 18 from each side. So 29x equals 52. And then divide each side by 29. So 52 over 29. Is there a common factor between 52 and 29? I think no. So the solution is only this fraction. Okay, so when an equation contains denominators in fractions, then find the LCD and multiply each term in the equation by the LCD so that we can remove the denominators. Okay, next example is about what if there's no solution or infinitely many solutions. So let's try some examples. Okay, now we can classify an equation into these three types. One is conditional equation, identity, and the contradiction equations and conditional equations. Okay, contradiction equation means there's no solution. For example, okay, when we solve an equation, we sometimes have something like this. False statement like 3 equals 4. We need to find variable x, but in this case, the variable is gone, and then what we have is this is false equation like this. Then this is a false, right? False statement, isn't it? This is not true. And then this means that there's no solution. There is no solution at all. So we cannot find the variable x to make that makes the equation true. And identity equation means, all real numbers, x can be any real number. For example, sometimes we have a true statement like this, 3 equals 3. This is a true statement. So whenever we have a true equation, then we can say that any value of x will make the equation true. That's identity. And then a conditional equation is we get some x value, x equals 2 or x equals 3. So that is the exact solution. All right, so let's classify the following equations. Okay, the first one is x plus 1 equals x plus 4. So let's collect x term to one side. So minus x each side. Then we have 1 equals 4. Look at this. 1 equals 4 is false, right? So we cannot find variable x, the value of x, so that the equation is true. So we cannot find any value. So this is always false. So no matter what the value of x, the equation is always false. So this is a contradiction equation, right? Contradiction. So that we can conclude that there is no solution. How about the next equation? Okay, let's try. So minus x each side. Then we get 3x plus 3 equals negative 9. And then minus 3 each side. So 3x equals negative 12. So x equals divided by 3. So negative 4. That is the exact solution, right? This is a solution. So this is a conditional equation. Conditional equation. Okay, next one. Then probably this is identity, right? It looks like the third one is identity, but let's try. So distribute each term inside the parentheses by 5. So 15x minus 10. And distribute next one, so negative 7x. And then plus 28 equals 8x plus 18. All right, then combine the like terms. So 15x and minus 7x will become 8x. The negative 10 plus 28 is plus 18 equals 8x plus 18. Look at this. The left-hand side and the right-hand side are actually equal, right? Anyway, let's move 8x from the right to the left. So we have 18 equals 18. This is always true, isn't it? This is true. No matter what the x value is, this is true. So this equation is type of what? This is an identity, isn't it? Identity equation. So that means there are infinitely many solutions. So all real numbers are the solutions. Okay, now absolute value equations. Okay, absolute value means always is positive and it cannot be a negative. So for example, let's say absolute value of, what is absolute value of 3? 3 is positive, right? So the absolute value is also positive 3. If negative 3, there's a number negative 3, and if you want to make an absolute value of negative 3, absolute value of negative 3 means always the value should be positive. So make negative 3 Positive. So I want to make this number negative 3 into positive. How? Multiply negative, right? Make it opposite. So this will become positive 3. So always, no matter what the value of x, if x is positive or negative, this is always what? Always positive. This one is always positive. Cannot be a negative. So if we have something like this, if we have an expression like this, negative 2, then what? Absolute value cannot be a negative, right? So in this case, there's no solution. So no matter what the value of x, always the absolute value will become positive. It cannot be a negative. Cannot be negative. So in this case, there's no solution, right? So this is how we can solve an equation, absolute value equation. So whenever we have absolute value of something, this is absolute value symbol, is positive number. Okay, let's say a is a positive number, because if a is negative number, then there's no solution, right? So let's say a is positive, then we can write the equation we can write two equations like this: x equals a and x equals negative a. Always it generates two equations. Actually, look at this. Let me rewrite it. So if x is positive, greater than or equal to 0, then what happens? Just like this. Just like, absolute value of 3 is just 3. 3 just remove the absolute value. So that we have an equation, x equals a. Can you see it? Since x is a positive number, it's already a positive number, so remove the absolute value symbol. So the equation looks like x equals a. And the second case is if x is negative, let's say negative 3, x is negative 3, then what did we do? We just multiply the negative number by negative to make it positive, right? So since x is a negative number, what we're going to do is multiply x by a negative number. This is second equation. Negative number, so that we can remove the absolute value symbol. It looks like a. So multiply each side by negative, then x equals negative a. So can you see it? We have an equation, x equals a, as it is, with removing the absolute value symbol. And the second equation is what? Negative sign should go to the left, but once we multiply the equation by negative, the negative sign goes to the right. So we have two equations. So whenever you solve an absolute value equation, always it generates two equations. So let's try another example related to the absolute value equation. Okay, now solve absolute value of 2x minus 5 equals 21. Look at this. The expression inside the absolute value symbol is 2x minus 5. Depending on the value of x, this expression can be positive or negative, right? So we can make two equations. First equation is, let's assume that 2x minus 5 is greater than or equal to 0. There are certain x values to make this expression positive. Then what do? Remove the absolute value symbol. Remove it because 2x minus 5 is positive, right? So 2x minus 5 is positive, so just remove it. So we have an equation like this. Okay, the second equation is what? Or. I'm going to use or. The second equation is if 2x minus 5 is less than 0, it's a negative number, then what do? What we did is multiply this expression by negative, right? So this will generate it, multiply each side by negative, so it will be negative 21. Can you see it? So we have two equations, this one and this one. All right, then let's find x from the first equation. So plus 5 each side, then 2x equals 26. Divide each side by 2, right? 2. So that x equals 13. So we found one value of x. And then from the right hand side, okay, we do the same thing. Plus 5 each side. Then 2x equals now negative 16. And then divide each side by 2. So x equals negative 8. So we found two values of x. So when we plug in 13 and negative 8, then the absolute value equation will be true. Okay, so this is really important. Absolute value equation will generate two equations. Okay, so one is without the absolute value symbol, and the other one is put the negative sign on either side by removing the absolute value symbol. Okay. Okay, let's solve this equation. Okay, d equals the absolute value of 135 minus 60t. Then when the value of d is 15, let's find t. Okay, so substitute 15 for d. Then we get this equation. So since this is an absolute value equation, so we can write two equations, right? The first equation is remove the absolute value symbol because the expression inside the absolute value symbol is 135 minus 60t. Let's say this expression is positive. So if this is positive, then we can just remove the absolute value symbol. Then the second equation is if the expression 135 minus 60t is negative, then we got to put the negative sign outside, right? We need to put the negative sign outside the expression by removing the absolute value symbol. So the second equation is actually the same as multiplying each side by negative. So negative 15d. D is replaced by 15, right? So we don't need this guy, right? So 15 equals 135 minus 60t. All right, so we have these two equations. So from these equations, let's find the value of t. So minus 135 each side. Then this negative 120 equals negative 60t. And divide each side by negative 60. So negative 120 divided by negative 60 equals 2, right? So t equals 2. We found the value of t, which is 2. And then from the second equation, let's find another t value. So minus 135 from each side. Then negative 150 equals negative 60t. And divide each side by negative 60. Okay, then the left-hand side is it 3 over 5 over 2, isn't it? 5 over 2. Divide by it, divide each side by 30. So t value will be 5 over 2. So there are two solutions. One is t equals 2 and the other one is 5 over 2. Okay, that is all for this section. Please do the homework in the exercise set. All right, then let's go on to the next section.